Hello YouTube, I'm R Peter. Let me go ahead and show you what we're going to be working on today. So, in a previous tutorial I made this coin explosion animation, but today we're going to be talking about how to add this blinking animation to the end to kind of show you when it's despawning. Alright, and we're going to do that using animation curves. So, if you want to learn how to make this coin explosion, check out the previous tutorial, and then if you want to learn how to make this blinking animation, keep on watching. Alrighty. So, for as far as our initial starting point, first off I want to say that there is links in the description if you want to download the code. Aside from that, you can follow the coin explosion tutorial, which will be linked to as well. And also, another tutorial you might want to watch is my initial animation curves tutorial. I'm going to be essentially covering the same stuff in this tutorial as I covered there, except that tutorial will cover about 50% slower for people who want more details, but this one should still be pretty easy to follow. So yeah, we're going to be doing all our work today in this coin, and we're going to go and make an animation curve for that coin. And spoiler alert, the way this is going to work is I'm going to be having two invisible frames. That seems to have that nice blink out, blink in animation. But then the thing we're going to vary over time is how many visible frames are paired with that. So in the beginning, maybe we'll have it be visible for 20 frames and then be invisible for 2 frames and kind of like alternate on that pattern. And then we'll be decreasing the amount of decreasing the amount of visible frames over time, and that's what we'll be doing in this animation curve. So I'm gonna call this, what am I doing wrong? Laptop mode, yep. I'm gonna call this nm despawn, and then since the y-axis is gonna represent how many visible frames, going to need to adjust this range somewhat. So I'm going to go ahead and make the upper like 25, make the lower 0. So I'm going to start the game out at about 20. So I'm just looking right here to get a sense where 20 is. Right there. And it doesn't need to be perfect. That should be just fine. Then I want it to just stay at 20 until I'm ready to go to the next one. I feel like having a sharp drop off, that contrast makes it very clear what stage we're on, as opposed to a smooth one. Then we'll have it go down to about 4. That's like a much more urgent feeling animation. So pretty simple. That's all I want to do for this. You can of course experiment more with this. You can add more steps. You can try and make it smoothly animating faster. I actually haven't tried that. I have this intuition that it won't work, but please try it. I'd be curious if it works. I don't have a ton of experience with experimenting with animation curves just yet. So now we're going to go ahead and jump into the coin, and just to kind of walk you through, in case you haven't followed the other tutorial, let me see. Some of this logic is based off movement, but the coin has another set of logic here about despawning, where if it hits the player it'll destroy, but also if it reaches the end of this timer logic it'll also destroy. So the only relevant thing for the timer logic is this thing. These other variables are about friction and gravity and speed, which you can follow the tutorial if you want to learn more about that stuff. So we have the despawn timer, which I'm going to increase somewhat, maybe make that like 7 seconds. And then I'm going to make another variable called despawn nm steps, something like that. So this way there'll be like 7 seconds until it starts despawning, and the last 4 seconds of that I want it to be in the animation stage, so it's not going to be following the animation curve for the whole time. And then I want another variable called invisible frames. So the animation curve is only varying the visible frames, and then I'm going to have a constant number of invisible frames paired with that. That's how I'm setting this up. Okay, so that's all for that section. Now in this section, we still want this logic here with despawn timer is less than 0. I want it to destroy, but then we're going to have another logic section where if the despawn timer is less than the number of nm steps, then we're going to be in our animation phase and we need to apply our animation logic. And just to clarify, the way this despawn timer variable works is it starts off with this 7 seconds worth of steps. It'll constantly be decreasing, and once it reaches 0 it'll destroy. So that's how this logic works, where if it's less than, then we know that we're close enough to the end that we're in the animation phase. So in all of my animation tutorials, I use the CX variable to represent our X position along the curve. In this case, we want our X to be at 0 when our despawn timer is equal to this animation steps, because that's when we're just starting our animation curve, and then it's going to be at 1 when despawn timer is at 0. So I'm going to do that deal. So this will get us halfway there. It'll be 0 when despawn timer is equal to animation steps, but then it'll be equal to, instead of being equal to 1 when it's when the despawn timer is at 0, it'll be equal to despawn anim steps minus that, which is equal to just despawn anim steps. So in order to get that to be 1, we need to take this whole thing and then divide it by that. And that should pretty much get us there. Let me think if there's an easier way to do this. I don't think so. It would be interesting to have like a reverse lerp function, because that could make this more intuitive, but this should work. So that will progress us through animation nicely. Next, whenever you are working with animation curves, you need two functions. You need to retrieve the channel, then you have another function to evaluate your position at the channel. So I'm going to call getChannel over here to retrieve the channel, and the first parameter is which animation curve, and the next one is which channel within the animation curve. So 0 would be the first channel. Then next we have visible frames, and this is essentially our y value along the curve, but I'm calling it visible frames to make to give it a more descriptive name, which I think will help us here. And then we're going to call anim curve evaluate. There you go, channel evaluate. And we have to pass in the channel and our X position along the curve. So this will either be 20 or 4, the way we set up our animation curve. So now here's the fun part, where we're going to use our visible frames in conjunction with invisible frames to figure out whether we should be on or off, visible or not visible. So what I'm going to do is I'm going to create a temporary variable called I. I'll just go and write it out and I'll explain in a second. Okay, there we go. This I variable will be very helpful to us. So what it does is it simplifies our despawn timer. Because when we have our visible frames and our invisible frames, let's say we have 5 visible frames and 2 invisible frames. So it'll be on for 5 steps, off for 2 steps, on for 5 steps, off for 2 steps. So you can essentially think of it as our despawn timer. It might be counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and onwards, but we really only care about the 7, right? Because it's 5 on, 2 off, so it's a total of 7 that we care about. So by doing percentage sign, or the remainder, we are getting what's left over after we divide by 7. So then instead of this number ranging from like 1 to 60 or 1 to like a few hundred, however much this ranges, it will just range from 1 to 7. And as we're counting down, this variable will essentially, instead of going like 10, 9, 8, 7, 6, 5, 4, 3, 2, it'll be going, let's see, it'll be 6, 5, 4, 3, 2, 1, 0, 6, 5, 4, 3, 2, 1, 0, 6, 5, 4, 3, 2, 1, 0. So this is kind of a nice way to cycle within the range. So now that we have this I variable, which is constricted between whatever our visible plus invisible frames is, we can simply do this deal. So if I is less than our number of visible frames, then we want to be visible. But then if it's in the upper part of that range, then we know it's in the invisible section. So if in our example where we said visible frames is equal to 5, this will be true if our I is equal to 0, 1, 2, 3, or 4. So there's 5 different indexes where this statement will be true. But then if it's in the upper range of that, 5 or 6, then it'll be in the invisible section, and this statement will be false. So I'm quite proud of that. I think it's a little bit clever, and it's a quick way to do this sort of logic where it'll like alternate on by the number of visible frames, off by the number of invisible frames. And I encourage you to plug in some numbers here and experiment with this modulus operator to dig into it further. Okay, I think that's all. Relatively short amount of code, even though it required some explaining. Okay, so we click, and then we have the despawn animation happening. Very cool. Yeah, and then from here I encourage you to play around with this despawn animation. Add more steps, maybe try adding a smooth decrease like that and see how it feels. Okay, so that's all for this tutorial. So before you leave, there's a few things I want to mention. This is part of a series where I'm taking a basic platformer and I'm trying to pack it with as many animation curves as possible to try and add a bunch of polish, and it just looks really great when you add animation curves. Something I try to do in this series is at the end of each video I like to talk about a different animation principle, because when people start out with animation, one of the first things they learn about is the 12 principles of animation, and Alan Becker has made videos for each one of those, and I refer you to one of his videos every time. So the principle I'd like to talk about today is called timing. So you saw here that with a different number of frames and kind of a different ratio of invisible to visible frames, it gives a very different feeling to the player. I'm not entirely sure if this is learned through just gamer logic or if it's something that's actually intuitive, but you can kind of tell that the 4 frame 2 frame ratio feels much more urgent than the 20 frame 2 frame ratio. The exact number of frames you pick, the timing of it, has a very different impression on the user player. So that's the gist of the timing principle, as I understand it at least. For more detailed, take a look at Alan Becker's video on it. So that is all for today. Thank you so much for watching, and I look forward to seeing you in more animation curve videos in the future.